All right, good morning. We are going to get started with our Stidigad. So let's go. All right. So number one, a lot of vocabulary with our transformations. Again, we have a lot of rules for transformations. I typically remember the following rules. For reflections, I tend to memorize the y equals x and y equals negative x reflection equations, which is x comma y becomes y comma x, so they flip spots, and then x comma y becomes negative y comma negative x. And then I think it's worthwhile memorizing your rotation rules. So I'm going to do rotate 90, rotate 180, and rotate 270. And these are all for counterclockwise. And so my rule for these is I'm just going to write the rule. I know it starts with x comma y. So this is negative y comma x. This is negative x negative y. And this is y comma negative x. I think if you can have that in lockdown in your memory, because the rotation ones are harder. Everything else, you'll have some graph paper, and you can figure it out. For rotations, I'll let you have Patty
paper too, so if that helps. But I just think it's way easier having the rule. All right, so translate. So translate, it says negative 4, 6, 5 units to the left. So left, again, means I'm going to go negative on the x, and 5 units down is negative on the y. So I'm going to go negative 4 minus 5, so that's going to be negative 9. And I'm going to go 6 minus 5. Again, it's x comma y, and so that's going to give me 1. So rotate counterclockwise 90, so I just have to apply my counterclockwise 90 rule, which I just flip them right away, and then I say, oh, this is change its sign. So that should be positive 6 comma 3. Another thing that's a good idea is just to quickly think, where is 3, negative 6 on your graph? Well, it's going to be positive on the x, but negative. So it's somewhere down here. And if we're going 90 degrees clockwise, counterclockwise, we should be up here in the positive. So this should be my prime or my transformed one. And notice my answer is in the right quadrant. Like I should be going up into that positive quadrant. Okay, so that's a good thing to like kind of just check real quick. So this is 90 degrees clockwise. So if you guys recall from our notes, 90 degrees clockwise is the same as 270 counterclockwise. So I'm going to use this rule right here, which is basically, again, flip them, but then change the sign of the back one, negative 6, negative 3. Again, I'm going to real quick graph that. That's in this quadrant. 90 degree clockwise should take me to this quadrant, which is right, because that is the only negative, which is quadrant 3. Rotate 180, I just should change the signs, so negative 5 becomes positive 5, and positive 8 becomes negative 8. And again, we can do the same thing. Negative 5, positive 8 is up here. If I go 180, I should be in positive x, negative y. So that looks good. Okay. Reflect over the y-axis. So again, if you don't know the rule for reflecting over the y-axis, we can go ahead and just utilize a graph to help us on this. So I'm going to go ahead and pull up a graph real quick just to see where this would end up and make it a little bit easier. So I just have a graph right here. We have 2, and then negative 10, which is way down here. Reflecting over the y-axis, so I should go 2 this way, 2 this way, and then 2 more over. Yeah. So it's negative 2 comma 10. So negative 2 comma negative 10 right there. And again, if you memorize the rule that the x just becomes negative, then you're probably pretty good. This one right here, 3, negative 8. So negative 3, negative 8 is down here. And we're reflecting over the x-axis. So I'm right here, negative 3, negative 8. So I'm going to go 8 up and then 8 up here. So that's going to be at negative 3, positive 8. The y equals x line, again, I just refer to my thing. I just flip them. So that's 3, negative 7. I flip them and change the sign. So that's 3, negative 7, but then that becomes positive. That becomes negative. And then number 9, reflect over the y equals negative 2. This is where it's good to have a graph. So y equals negative 2 is going to be this line right here in blue. There we go.
And so we're at 6 on the x. 1, 2, 3, 4, 5, 6, and then negative 4. 1, 2, 3, 4. So it's 2 away, so I'm going to go 2 above. So I'm at negative 6 comma 0. And there we go. All right, match the definition with the vocabulary. So collinear is all points that lie on the same line. So that should be right there. F. Midpoint formula. So we haven't talked about midpoint formula or distance formula. So I think those are our old ones, so we can kind of skip those. But midpoint formula is C. Distance formula is D, just in case you're wondering. Those are old equations that we haven't really talked about fully yet, so sorry about that. Segment bisector. So we're looking for a segment, line or plane, no. The measure of 2 segments, no. Angles, points, the measure of 2, no. No. A ray that divides an angle into 2 congruent angles. Segment bisector. I guess that might be, oh, here it is. Yeah, right here, G. A segment, line, or plane that intersects a segment at its midpoint. Sorry, I read right past that one. A plane. A flat surface that extends indefinitely in all directions. There we go. That's a plane. Congruent angles. So we got that one. Angles that have equal measure. There it is. Angle addition postulate should be the adding of 2 adjacent angles that add up to a larger angle made up the outside side. So that's it. Okay. And segment addition, the measure 2 segments add up to the H. Okay. A basic term that has no side and is represented by a dot, that would be a point. Just in case you wanted to know. A ray that divides an angle into 2 congruent angles, that would be a angle bisector, not a segment bisector. That's why I was stuck on that one for a second. And then points that lie on the same plane, that would be planar. Okay, so just fill in those other vocab words in case you're wondering. All right, moving it on to the back. Let's go ahead and get started with these. Okay, name the intersection of the line and the plane. That would be at point H. Name 2 points that are coplanar. M and H are on the same plane. Name 2 points that are collinear. H and D are on the same line. If A is the midpoint of CM, find the length of AM. So here again, I usually like to draw a picture. A is the midpoint of CM. That means those are congruent automatically. That's what the word midpoint means. And we get 2x minus 3, and we get 5x minus 11. So we're just going to set those equal to each other. And when we set those equal to each other, we're going to subtract the 2x from both sides. While I'm actually going to add the 11 as well. So that cancels that. Negative 3 plus an 11 is going to give me 8. And then we're going to have this cancels here. 5, that's 3x. Okay. And then we're going to go with divide by 3. And x equals 8 over 3, but then it says find the length of AM, which is the total length, so we just got to plug it back in to solve for this. And so we're going to plug it into this one, so we get 5 times 8 over 3 minus 11, so whatever this comes out to, it's going to be double that, so I'm just going to do in our calculator here, I got my calculator, I'm going to do 5 times 8 divided by 3, because it's essentially the same, then subtract 11. Okay, so that's about 2.3, so we get 2.3 repeating and 2.3 repeating, so if we double that, we're going to get about 4.6 repeating for AM. Okay, I believe on the test everything comes out to a whole number, but there we go. A little decimal fun for everyone. All right, next, moving on. The following diagram, C is the midpoint of AE. Okay, so if it's in the midpoint of AE, that means these two are congruent. B is the midpoint of AC. That means, a different color on that one. That means this and this is congruent. If AE is 28, so if AE is 28, that's the whole thing. I'm going to split that in half right now. That's 14 and 14. CD is 3, and, 3 right there. And AB is 7. Find the values below. Okay, well, not too bad, because if that's 7, we know that's 7. And that's 7 plus 7 is 14. That's 3. And if this whole thing is 14 and that's 3, then that means if we do segment addition postulate here, take the 3 from the 14, we should get 11. Okay, so DE is 11, and then AC is 14. Okay, that one you just have to kind of read carefully. R, S, and T are collinear. S is between R and T. Okay, so we got R, T, S is right here. RS is 2W plus 1. ST is W minus 1. And then RT is 18. So here we're going to use our segment addition postulate, just add them together. So 2W plus 1 plus W minus 1 equals 18. The ones are going to cancel out. We don't add them across. It's just plus 1 minus 1 is 0. 2W plus W is 3W equals 18. Divide by 3, and W should equal 16. I'm going to double check. Or 6, I apologize. So W equals 6, and then ask for RS. So we're going to do 2 times 6, which is 12 plus 1, so we should get 13. All right, factor completely. So we will see factoring on the test. So again, this is basic factoring. What multiplies to 24 adds to negative 14. So start listing out all your factors of 24 and say, which one of these would make 14? 2 and 12. Right there I see 14, so 2 times 12. So I'm going to do negative 2 and negative 12. And then we can go right to our answer. So we're just factoring. Now this one we have a whole number in front, so look for a GCF first. So the greatest common factor. It looks like I can divide all these by 2. So I know 2 is going to be in my final answer. But I'll be left with x squared minus 7x minus 44. And then so I want to do what's negative 44 and makes a negative 7. So here I got to go ahead and go through my factors of 44. So 1 and 44, 2 and 22, 4 and 11. And I'm thinking 4 and 11 is the one that's going to make it happen. So negative 11, positive 4. So I get x plus 4 and x minus 11. So again, I have to leave that 2 there because I did factor out a 2 first before I got into it. This is exactly the 2 questions you're going to see on your test. So, boom. All right. KJ and KM are opposite rays. So that just means that this is a straight line. So if you go from here all the way to here, that's 180 degrees. KN bisects JKL. So that means that this angle right here and this angle right here, they're congruent. Make sure to draw congruency marks. So I just marked those. So I think we're going to be using the 3 problems here with this picture, but not necessarily they all go together. So they're using the same picture, but they're not the same values. So JKN is this angle here, and NKL. So we're referring to these 2 angles. Well, they're congruent, so all I have to do is set those 2 equal to each other to solve for that. If I look at my picture, that's it. Okay, so I'm going to subtract the 6x. Sorry, that is supposed to be subtract 6x on both sides. That gives me 2x. I'm going to add the 13 over at the same time. That's going to give me 24. Divide by 2. X is going to equal 12. And it says find JKN, so you plug it back in. That's going to be 8 times 12 minus 13. 8 times 12 minus 13 is going to give you the measure of JKN to be 83 degrees. All right, next one, JKL. So JKL is this whole big angle. and JKN is only this little half angle. Find it. Well, JKN is this little half angle. We'll go ahead and write it in on this one. So JKN is 5y plus 2. Well, this one's also going to be 5y plus 2 because they're congruent. And then it says the whole thing, JKL, so from here to here, is 9y plus 15. So I should just be able to add these two together to get this. And again, I had 5y plus 2 twice because it was said to be congruent. So here we go. We get 5y plus 2 plus 5y plus 2 equals 9y plus 15. Combine like terms. Again, we're not adding or subtracting because we're not going across. So that's 10y plus 2 equals 9y plus 15. I'm going to subtract the 9y to get y. I'm going to subtract the 2 over here to get 13. And boom, y equals 13. Find JKL. So plug it back in. So we get 9 times 13 plus 15. I'm going to use my calculator so I don't mistake anything. And we get a pretty big answer here. This is 132 for the measure of JKL. Again, these measures don't go with each other. They just use the same picture. And then it says, suppose JKN is 3x minus 30. So now we got to be like, oh, shoot. We got to reuse this picture. Okay, so JKN is this guy right here, is now 3x plus 30. And L, okay, LKM is 2x. Well, if this is 3x plus 30, this is also 3x plus 30. So what they're doing is they're giving me all three now angles, and we know all three angles should add up to 180. So this angle plus this angle plus this angle, or basically, right, this guy, and this guy make the whole 180 degrees. So I'm going to add up all three of them, set equal to 180. That's my goal. All right, so 3x plus 30, and then I get to do it again because they were congruent, plus the 2x that they gave me, 180. Combine all these like terms, 3 plus 3 plus 2 is going to give me 8x. Plus 30 is going to give me 60. I'm going to subtract the 60 to get 120. And then 120 divided by 8 is going to go in 15 times. So there's my x value. And then NKL is going to be the 3x 30. So that's 15 times 30 plus 3 times 15. I'm sorry. Plus 30 is going to give me 75. So the measure of NKL is going to give me 75 degrees. All right. Woo. Next one. All right, find the x and y in the image below. All right, so we could do a couple things here. One, I could do vertical angles, but that's a y and that's an x. Can't set an equation equal with y and an x. But I can do this. This is a linear pair. This adds to 180. Okay, so we know linear pairs add 180. So if they create a straight line, they add 180. So I'm going to add those together to create 180. Okay, 9x and 25x should give me 34x. 8 plus 2 is 10. Subtract the 10, and I should get 170. And 170 divided by 34 is going to give me x equals 5. Now, I want to set these two equal to each other, so I'm going to get 7y plus 5 equals 9 plus 2, but I know what 5 is now, so I'm going to plug in 5, because those are vertical, so we should be able to set them equal to each other. So 9 times 5 is going to be 45, plus 2, which is going to give me 47. So we get 7y plus 5 equals 47. I'm going to subtract the 5 to give me 42, and then 42 divided by 7 is going to give me y equals 6. Alright, so I had to kind of solve the x first before I can solve for y. But again, I'm just using principles of linear pair, vertical angles, and then some algebra. Okay, if we weren't done yet, we still got some more. Supplementary angles. Okay, what do? They add 180. So we're going to get 4x plus 8x equals 180. That's just 12x equals 180. So that one's pretty easy. Divide by 12, and we get x equals 15. And then it says find the measure of each angle, so it's just 4 times 15. So that's 60, and 8 times 15 is going to be double that, 120. Those do add to 180. Complementary, add to 90. So we're going to do the same thing, x plus 24 plus x equals 90. I'm going to subtract the 24 from 90. So if I subtract 24 from 90, I'm going to get 66 equals 2x, so x must equal 33. And then here it says x is, well, 4, so that's 33. And then 33 plus 24 is going to give me 57. And if you add those together, that's also 90, so that works. Two lines intersect to form an angle. The two adjacent angles formed are 4x. And what is the measure of those angles? Okay, so two lines intersect to form angles. The adjacent ones next to each other is 4x and 5x minus 27. So this is a linear pair, basically is what it's trying to get you to do. So you want to add them and set it equal to 180. Okay, so that's going to be 9x. I'm going to add the 27 over, so that's going to become 207. If I do my math right there, and then divide by 9, we get x equals 23. And then we just got to plug it in to each of these, so I'm just going to do it on my calculator. So 4 times 23, so I get 92 degrees, and then 5 times 23 minus 27 should give me 88. And just to be safe, is 88 plus 92 180? Yes, it is. Okay. Vertical angles. So vertical angles are congruent to each other. Good to know. So we're going to just set them equal to each other. Subtract the 4x. That's going to give me 12x. Add the 9 over. That's going to give me 12. So x equals 1. And I just got to plug them in. So that's really just going to be 16 minus 9, which is 7. And then 4 plus 3, which is 7. And guess what? They equal each other, which is what they're supposed to do. And last but not least, linear pair means add to 180. So we're going to get 4x plus 5x minus 27 equals 180. And goodness gracious, this looks very familiar because this problem and this problem are the exact same values. And since we're doing the same setup, we end up with the same answer of 92 and 88. Which isn't that cool. Saves me some time. All right, the table below shows the coordinates of a square and then a transformed square after transformation. What are the coordinates of point x and what is the transformation? Okay, so we basically are trying to figure out how am I going from what to what. And let's take a look here. So I see that none of the values are the same, so I'm thinking this is a translation. Because most of the other rules, it's just switching the y and the x and the negative. So here I'm at -2, I went to -6. So I'm thinking x minus 4. Let's see. 6 minus 4 is 2, 1 minus 4, yeah. So I'm thinking the rule is x minus 4, and then let's look at 1 goes to 0. So I'm thinking subtract 1, -1, -2, -4, yeah. So I'm thinking y subtract 1. And so here, subtract 4, I get -1, and I subtract 1, and I get 3. Okay, so you kind of just look for the pattern in what you have. Write an algebraic rule and coordinate notation for a translation that moves a triangle 5 units to the left. Left is going to be x minus, and up, y plus. So this is going to be x minus 5 and y plus 6. Okay. Here we're going to transform across the y equals -1 line. So here we go. No rule for this. We just got to graph it. So let's go ahead. I'm going to get a is at -1, 2, 3, +1, 2. Okay, and that means we're 3 units away. 1, 2, 3. So I'm going to go 1, 2, 3. And there's my a prime. There's my a. -1, comma 6. 1, 2, 3, 4, 5, 6. There's b. And we're going to be the same thing, but we're going to be 6 units away. And here's b prime. Oh, sorry, I did that wrong because we're counting not from here. So that's actually 7 away, so I'm going to be on this one. I believe, let's just double count. 1, 2, 3, 4, 5, 6, 7, yes, and then 1, 2, 3, 4, 5, 6, 7, yeah, sorry. So it's going to be this guy right here, B prime, right on the edge. And then last but not least, we got C, which is at 6, positive 1, 2, 3, 4, 5, 6, up 1. That's going to be C, and that's 2 away, so we're going to go 2 away. There's C prime. And so we should have a triangle like that. We should have a triangle like that. And it should look congruent. They look like congruent shapes, the same size. So A prime, like I said, is at -3, -1, 2, 3, 4. B prime is at -1, negative, I think that's 1, 2, 3, 4, 5, 6, 7, 8. And C is going to be at 6, comma, -1, 2, 3. There we go. All right, reflect JK over the y-axis, then rotate 270 clockwise. Okay, so we have to do basically double transformations on this. Now, if you remember the y-axis, if I'm reflecting over the y-axis, which is this guy, it's really just the x value changes. Okay, so first of all, I'm just going to write my original points. I think that will just make it a lot easier. K, L. So L is really easy. It's just at 1, comma 0. That one's really easy. Then I'm at 1, 2, 3, 4, 5, 6, 7, 8, positive 1. And then you are at 1, 2, 3, 4, 5, 5. And then up 1, 2, 3, 4, 5, 6, 7. Okay. So for my prime, I should just reflect it across here. So however far away it is over there, it's that far away. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's J. So whoop, whoop, and whoop. Okay. So what's interesting here is that all I have to do is really change these into negatives, and we should be good. -5, 7, -8, 1, -1, 0. All right, now I'm going to take this and rotate it to 70 clockwise. So we got to be careful. It says clockwise right there. So we remember our rule. Clockwise is the same as 90 degrees, counterclockwise. So it's really going to end up in this quadrant somewhere, okay? And so my rule, and I'm just going to write my rule right here, is -y, comma x. So I'm going to apply the rule, and then I'm going to graph it and see if that was correct. So I'm going to switch them and make the front one negative. Can't make 0 negative. Okay. Whoop. All right. So what we see here is that I'm in all negatives, and this quadrant is where I want to be, because this would be 270 clockwise or 90 degrees counterclockwise. You end up in the same spot. So I want to be here. This is the negative quadrant, so that makes me feel good that I did go to the right spot. So I'm going to go -7, -1, 2, 3, 4, 5, and there's J double prime, -1, -8, and there is K prime prime, and 0, -1, there is L prime prime. Again, really hard to rotate this by yourself, but we could use patty paper, which I'm going to show and demonstrate real quick. So if I draw in my y and my x axis, we should be able to locate this. So again, let's make sure we're good. So right here, here, and here, that's my K, J, and L. Okay, and so I put my pen right here. Now if I go 90 degrees like that, it lines up pretty perfectly with the J, K, and L. Again, that's, but it says clockwise, so technically clockwise I should go 3 times this way. 1, that's 180, and 270. Still wind up in the same spot. So if you can't memorize the rule, I will be giving you guys some of that paper. Okay? Whew. This is a long one. I'm sorry, guys. We're in for like the long haul. All right. Clockwise, then reflect over the x. All right. Rule for transformation. Let's do this one. I just got to take a break from doing the double there, huh? That was brutal. All right. So I'm going from here. Just remember, I'm going from this shape to this shape. Rule for the transformation. This has has to be a translation. So I'm just going to count how many have to go back. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be x minus 9. And then I have to go up 1, 2, 3, 4. Y plus 4. Okay, that one was relatively easy. All right, this one, write a sequence of two transformations that will map the pre-image, so this guy, onto the image. So we have to do a sequence here. And the first thing is to try and get into the right orientation. So I'm actually going to, again, use my patty paper. This is the easiest way to do these. Use the patty paper. I'm thinking it's a rotation, not a reflection, because we want to get everything in the right spot. And then I think it's going to be a translation. So I think we're going to rotate, and then we're going to translate. Okay, so let's see if I can do that. Okay, so I want to rotate this so in is at the top. So if I go there to there, see how I look like I'm in the right spot now? I got my MLN. So I'm going to rotate 180, it looks like. Okay, and then it looks like I need to come down 1, 2, 3, and then over 1. Okay, so again, that was rotate 180, and then I need to translate, so that's rotate, and then we're going to translate, and let's do it again just because, you know, don't want to mess up. So I rotated 180, and then my x value, I need to go 1 to the left, so that's x minus 1. So we're going to do x minus 1. Oh, that's supposed to be a comma, sorry. And then we're going to come down 1, 2, 3, and we'll get right into the spot, y minus 3. Okay, so sometimes trying to map those can be tricky, but using a patty paper makes it a lot easier. All right, last but not least, let's do this guy. And you know what? It asked me to rotate clockwise, then reflect. So I'm just going to go ahead and we've been using this little patty paper, same one. So we can use one piece of patty paper since these graphs are pretty small. That's what's up. All right. Oh, by the way, if you're doing the written part on the test, if you draw a picture of yourself as a Star Wars character, I'll give you extra credit. Don't tell anyone. Picture of yourself as a Star Wars character. Don't tell anyone, extra credit. So like you can make yourself a Jedi or like a stormtrooper or something like that, you know, Darth Vader, whatever. Okay, rotate 90 degrees clockwise. Remember, clockwise, I'm going to go this direction, not that way, or I'm just going to apply the rule of this guy, which is 270 counterclockwise. So let's go ahead. I'm going to rotate it, whoop, because this would be the right position here. And so I'm going to kind of, I didn't poke holes. That was dumb. So I didn't poke holes, so that's kind of unfortunate. Maybe I should poke holes real quick. Poke, 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 and poke. Okay, there we go. Let's see if I can get it now. Boom, boom. Where's D at? Right there, maybe. And A is right there. Okay. So boom, 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 boom. I think that's good. A, B, D, C. All right. Now, again, squares are hard to look at when you rotate them. So let's just double check. That looked good. That looks good. Okay, so let's see if the rule makes sense. My original points, let's get those down. I know this can be time consuming, so it's over 2, up 1, 2, 3, 4, 5, 6. So that's negative 2, comma 6. This is at negative 3, 2. We'll go negative 1, 2, 3, 4, 5, 6, negative 6. And then up 1, 2, 3, 4, 5, 6, 7. And this is negative 7, up 3. Okay, so according to the rule, I should do something y comma negative x. Okay, let's see if that worked here. Okay, so this should be 7 comma negative 6, but then make it positive. So 7 comma 6. 7 comma 6, that looks good. Yeah, that's right. This should be 6 comma positive 2 once I change that sign. So 6 positive 2, that looks good. Again, this is an 8 count, so that's how I'm kind of counting a little faster. I'm actually subtracting 2. This should be 2 positive 3, 2 positive 3, good. And this should be 3 comma positive 7, 3, and then up to 7. Yes. Okay, so that worked. Good. Now we got to reflect it over the x-axis. So again, here's my x-axis. If you remember the rule, the x value should stay the same. The y values just become negative. So this really should just go down here where all my y values are negative. So my x's really should all stay the same, and I should get negative y values. Okay, and so by the way, that was prime. Okay, so A is here, so it should be here. A double prime, 7, still positive, negative 6. B should be right here, double prime, 6 but negative 2, good. C is 3 over. Again, that looks good for C, 2, negative 3. And then D is right here, or double prime. And there's my shape. Okay, so again, just a little bit of time management on these, but take your time and you got it. All right, good luck. Hope you enjoyed.